Hello students, in this video I am going to discuss about the calculation of bond order during resonance. This is a very important concept for your all different types of competitive examinations. Is that okay? Fine. So we know from the molecular orbital theory that bond order of simple molecules or some of the heteronuclear molecules can be calculated with the help of formula. What is that formula, dear students? Yes, it is bond order is equal to number of electrons present in bonding molecular orbital minus the number of electrons present in anti-bonding molecular orbital divided by 2. So it is 1/2 of the difference between the electrons present in bonding molecular orbital and the anti-bonding molecular orbital. So this is your normal method to find out the bond order. Do you agree? Yes? Fine. Now what happens is this formula is applicable for simple molecules like hydrogen or even chlorine. Am I right? Or the oxygen, nitrogen, which you have learnt in your PU classes. Now what happens in the case of some species? For example, if I take the carbonate ion, how to find out the bond order in this case? The reason why I have taken this example because there is a resonance. So our today's video is all about finding bond order during resonance. Okay, so few examples we'll take now. Okay, so the trick goes like this, dear students. Okay, there is a shortcut method and this particular formula to be followed. What is that? Bond order in such cases where resonance is operating or taking place is this formula to be applied. That is, bond order is equal to total number of bonds, okay, present between two atoms in all the structures, when I say all the structures related to resonance structures, okay, all the structures to be divided by total number of resonating structures or resonance structures, total number of resonance structures. This formula to be remembered in order to calculate bond order if the given species is undergoing resonance. Is that okay? Now let me take few examples. So first one, very simple example let me take so that you understand this particular concept. That is, consider benzene. Okay, example 1, let me take example 1, benzene. So you know the two resonating structures of benzene can be written Kekulé structures, what we call in this form. Is that right? So shift the pi electrons, so you will get a double bond over here, next alternate position. So these are the two structures. So let me write first structure and second structure. Now the bond order calculation during this resonance goes like this. Bond order is equal to S, the total number of bonds between two atoms in all the structures. So you need to at the beginning fix two atoms. So let me take these atoms 1 and 2, let me number it. How many bonds are present between these two atoms, dear students? 2. Same two atoms to be considered in the other structure. So all the structure it is. So next it is only one bond between 1 and 2. So total number of bonds present between atoms 1 and 2 in both the structure is equal to 3 divided by how many resonance structures we have written, or it is possible to write for benzene? 2. So it is 3 by 2, which is nothing but 1.5. So this is a bond order for benzene. Is that fine? Yes. So let us extend our discussion or idea by taking two more examples which are asked in previous years different competitive examinations. Okay, last 10 years if you study, you'll come to know about these particular examples. So the example 2 I'll take as carbonate, okay, which already I told you there is a resonance in carbonate. So the resonance structures of carbonate ion to be written first, that you should know. Is that okay? So how to write the resonance structures of carbonate? Carbon, double bond O, now here single bond and here single bond. So you know this, isn't it? So CO3 2 minus, or overall charge can be written as 2 minus, fine. So I have written like this. So this is the first structure. Let me write the other possible structures of carbonate ion in this way. Okay, so resonance double-headed arrow, as you know, carbon, you shift this electron here so that bring the one negative charge to the carbon oxygen. So double bond O, here the negative charge and the other side. Is that fine? Okay. What about next one? Here, carbon, and you shift this electron now. Okay. Bring this pi electron here, because all the carbon oxygen bond to have double bond at least once. So I have here C, next minus charge, here the minus charge, and here comes the double bond. Okay, so double bond. So these are the resonance structures of carbon oxygen, that is nothing but carbonate ion. Is that fine? Yes. So you number the structures to total structures. How many? 3 are possible. Fine, no? Yes. Now apply the formula. Bond order is equal to, yes, I'll fix, okay, this top carbon and oxygen bond. So 1, here there are 2 bonds, totally 3, and finally 1 more, 4. So how many structures? 3. So 4 over 3, isn't it? 4 by 3. So the bond order is 1.33, point to be remembered. Is that fine? Yes. So will you go for one more? Yes. So example 3. Yes. I'll take the phosphate ion here, PO4 3 minus. Yes, task is to write the resonance structures of phosphate. Will you? Yes. So just observe here, phosphorus, you write a double bond over here. Next, tetrahedral unit it is. So oxygen minus, and here oxygen with minus charge and one more minus. So this is the first structure. Okay. Will you shift the bonds now? Yes, one at a time. Is it okay? So I have here left hand side oxygen with the double bond. Next 3 structures will appear where this double bond is shifting. Okay. So you write it, phosphorus. Now let me write double bond over here. So double bond O. Now this is your single bond, the other 2 as usual. This is the second structure. Go for the third one. Yes. So it is phosphorus. Now how did you get this, dear students? You bring here and this you shift. So this is what we call resonance. Okay. So now here also I am shifting and bringing double bond over the other place, right side. So here minus charge, this is your minus charge already, and here minus. Now this is your double bond. Will you write the last one? So this is the third structure. Okay, third one. Hope you will write it. How you shift this and bring double bond here. Is that okay? So fourth structure to be written. Okay. So I'll write symbolically here, phosphorus minus, here minus charge, now here double bond O and O minus. Thus, that is the fourth structure. Now you count or fix one of the phosphorus oxygen bond. Let me fix the first one, that is top PO bond. 1 plus 2 3 plus 1 4 and 1 5. So bond order is equal to 5 by how many structures? 4. So what is the value? It is 1.25. So in this way the bond order during resonance can be calculated by making use of the formula. Is that okay? Yes. So you try this for the different oxo acids of phosphorus, sulfur, or even for the chlorine, hypochlorous acid, chlorous acid, chloric acid. For these acids you can try and work out the formula so that you will come to the conclusion what will be the bond order. And definitely this is a very important type of question, dear students. Yes, so I hope you understood the particular concept in this, or whatever dealt in this video. And if you really like this, then please don't forget to press the like button, dear students. Yes, and also let all the other needy students get benefit out of it. So please do not forget to share as well this video. Okay, finally, to get more such type of videos, don't forget to subscribe this channel. Thank you, dear students.